A statistic is a characteristic about a sample and a parameter is a characteristic about a population. Generally speaking, when you are computing data, you will not have the data for the entire population. Now, that's not always the case. If I was using the data from this class, for example, and my population was my statistics classes, I've only got one stats class. So therefore, this whole class would be the population, and I would probably use it as a sample as well. But generally speaking, unless it specifies it is for the population, if it's giving you data, you can assume that it is coming from a sample, okay? When you're rounding, just like always, I've always told you this in math, it's really important here in statistics. Don't round till the end. Always go 2 to 3 extra decimal places until you have your final answer, and then you can round. So if I say round 2 decimals, round 4 until you get to your final answer. Because if you round an answer and then use it, and then round that answer and then use it, and then round, eventually you will be off enough that it's going to make your answer wrong. And unfortunately with statistics, the decimal points are needing to be accurate, okay? A measure of center is a value at the middle of a data set of numbers. The 3 forms of center are mean, median, and mode. Hopefully those are all ones that you are familiar with, but we're going to go over them just in case you've forgotten. So the mean or the average of a data set is found by adding all numbers in the data set and dividing by the number of values in the data set. A sample mean is the sum of all x values divided by n, where lowercase n is the total number of values in the sample. Population mean is divided by uppercase n. So you have to be able to know the difference in your variables as to which one's representing a sample, which one's representing a population. So uppercase N is population number, lowercase n is sample number. And again, assume the data given is from a sample unless otherwise stated. The median is a number that measures the middle of the data. It is the halfway point when the original data values are arranged in order of increasing or decreasing magnitude. If the number of data values is odd, the median is the number located in the exact middle. So if you have 5 data points, the third one is your median, okay? If it is an even number of data points, so if you had 6 data points, you would use the average of the 2 middle ones. So you'd find the third and the fourth and find the average of those. So determine the median of the following sets of numbers. So what do you have to do first? Put them in order from least to greatest or greatest to least. Generally, we do least to greatest. If that helps, you can number them or you can just count. And you find that your median, by the way, median is usually abbreviated MED. Sometimes it's just capital M, but MED is usually how I do it. The median is 147. All right, looking at letter B. Again, put it in order. So on this one, we have two values that are in the middle, so we're going to find the average of them. So my median is 39.5. Questions on median? Nope. Perfect. The mode is the number that occurs most often in a data set. A data that has only one value that occurs with the greatest frequency is unimodal, so one mode. Data set that has two values that occur with the same greatest frequency is bimodal. A data set that has more than two values is multimodal. So if you've got more than two, then it's just multimodal. You can have however many modes. The only time you don't have them, and you can also have no mode. If you have no mode, it means all of your data occurs at the same frequency. So they all occur once or they all occur twice. Okay? The mid-range is a rough estimate of the middle. It's found by finding the mean of the lowest and highest values in the set. So you find your smallest value, your largest value, and you average them. And that's a rough estimate of what the middle is. So that is your mid-range. It can be affected by extremely high or low data points, which we refer to as outliers. So it's not always accurate. So just know that. A weighted mean is used when values are not equally represented. Here at PCA, when you calculate your GPA, all of your classes are weighted equally. Okay? You have English and math and science and history, all of them are weighted the same. So you just add them up and divide. When you get to college, that is no longer the case. You will have some classes that are worth 1 hour. And by the way, the hours are like how frequently they meet, if you don't know in college. You may have a class that's worth 5 hours. Now, obviously, if you have an A in that 5-hour class, it is worth a whole lot more than the A in that 1-hour class. So they have to calculate this using what we call weighted means. The easiest way for me to show you how to do this is by actually showing you how to calculate it. So if we have this right here, your GPA, who has an A in English 1301, which was 3 credits, a C in Psychology 101, 3 credits, a B in Biology 1301, 4 credits, and a D in Math 100, 2 credits. And it tells you how many points they're worth. So if you look at your different classes, you have English 1301, Psych 101, Bio 1301, and Math 100. Then you look at what grade you made in each. In English, that was an A. Psych was a C. Bio was a B. And Math was a D. And then look at how many credit hours each class is. So to find your GPA points, if it's an A, it's worth 4 points. So you take that 4 and multiply it by the number of credit hours. A C is worth 2, so 2, and then again times the number of credit hours. A B is worth 3. And a D is worth 1. Does that make sense so far? Okay. To find your GPA, you add up your total points and divide by your total number of hours. Does that make sense to everyone? Yes? Okay, and so I wind up getting 32 over 12, which is a 2.667. Okay, like I said earlier, you have to make sure that you know symbols in this class. Sigma is the mathematical notation for the summation, the sum, add up everything, okay? X is just a variable used to represent the data. Again, lowercase n is the number of data points in your sample. Uppercase N is the number of data points in your population. X bar represents sample average. Mu, which is the one on the bottom, is your population average. So you have to know what each of those are. I don't write sample average. I write X bar equals. Okay, so you have to know what everything is. So is X bar a parameter or a statistic? Why? Because it represents a sample. Is mu a parameter or a statistic? Parameter. Okay. Using the table to the right, compute the population mean and median. Go. What do you notice happens when I have an extreme value that doesn't really fit in the data? What's affected? The mean, which makes sense, right? Median doesn't really become affected at all. So this is another just a visual example of what happens as well. Whenever you have an outlier, the mean is changed and the median is not. So we notice when we're looking at data, for this data specifically, is the mean or the median more appropriate to give you a best overall look at what the data is telling you? For this one right here. Nope, that is not right. If I go to a neighborhood and I'm looking at two neighborhoods and notice that one of them has an average value of 173,000 versus 153,000, that tells me two very different things, but those neighborhoods are not any different. So therefore, which one is a better description of the data? The median. The median isn't affected by outliers, therefore, in a lot of cases, median is what you should be using to describe the center of data, not the average. Resistance. If extreme values, very large or very small, relative to the data, do not affect its value substantially, then the data is said to be resistant. So, based off of our previous example, which measure of center is more resistant, mean or median? Median. So, therefore, which center is more appropriate when outliers are present? Median. All right, example 2. Sam has 20 rose bushes, but only counted the flowers on 6 of them. So he has a sample of 6. Sam's flower counts are 9, 2, 5, 4, 12, and 7. Find the mean and include the unit of measure and find the median. So go find mean and median. So properties and uses. So the mean is found obviously by using all the data values of data. It varies less than the median or mode when samples are taken from the same population, and all three measures are computed for these samples. It is used in computing other statistics such as variance. We're going to get into that soon. The mean for the data is unique and not necessarily one of the data values. It cannot be computed for the data in a frequency distribution that has an open-ended class. And it's affected by extremely high or low values and may not be the appropriate average to use. Median is used to find the center or middle of a data set. It's used when necessary to find out whether the data values fall into the upper half or lower half of the distribution. It's used for an open-ended distribution, and it is affected less than the mean by extremely high or low values. Mode is used when the most typical case is desired. It's the easiest average to compute. It can be used when data are nominal or categorical, such as religious preference, gender, or political affiliation. It is not always unique. It can have more than one mode, or it may not exist. And then mid-range is very easy to compute. It gives the midpoint, and it is affected by extremely high or low values. So that's just sort of characteristics that you may need to know whenever you're answering questions about those four things. All right, distribution shapes. So the bell-shaped distribution or the symmetric distribution, that's synonymous. You need to know either one. The highest frequency occurs in the middle, and the frequencies tail off to the left and the right of the middle. It will be used in our study of continuous probability distributions and will be known as a normal curve. So we'll talk about that a lot more later. Right skewed, which is positively skewed. The tail extends to the right of the peak longer than to the left. So again, we kind of talked about that. It has a tail. There are extreme values or outliers that are on the right. So the tail will also taper off towards your outliers as well. Left skewed is going to be negatively skewed. It extends to the left of the peak longer than to the right. There are extreme values to the left. So this is a visual, and you need to be able to look at these and determine with, like, if I give you these distributions, you need to be able to tell me roughly where the mean, median, mode are. Okay? So you need to know that when it is right or positively skewed, your mode obviously is always going to be the easiest one. The median is pulled to the right of the mode, and the mean is pulled even further right. So you need to know that. Whenever it is symmetric, they're all the same number, if it's perfectly symmetric. Okay? So if it's roughly symmetric, they'll all be close to here. If it is left skewed or negatively skewed, again, your mean is pulled towards the data, the outliers, and your median falls in the middle of that and the mode. So you need to be able to identify where mean, median, mode lie on those graphs without it being labeled. Okay? All right, sometimes you are going to be asked to find mean and the mean for frequency distribution that is giving you your groups. Okay? Now, you do not know what the data points are in this, so there's a specific way that they have us do this. The very first thing you do is you find your midpoints of all of your classes. So the first thing I'm going to do is I'm going to find the midpoints. Remember, midpoint is just averaging the upper and lower bounds. Okay? After you've done that, you are going to take the frequency and multiply it by the midpoint. So this is similar to your weighted averages. You're doing a weighted average here. And then just like with weighted average, to find the mean, you add up all of your, everything in that right column, and then divide by the total frequency. Okay, so my mean is 1768. My modal classes are the ones, and there's two of them, they're the ones that occur the most with most frequency. So those are both my modal classes. And then it asks to compare, and so you're going to look at the mean and then what it gives you for the mean in the problem.